Okay, so for the introduction part, okay, our topic is an off-grid solar photovoltaic system for the single-story residential house. Okay, so our group aims to offering a self-sufficient and sustainable energy solution that can help us to reduce the reliance on the power grid system. Okay, so there are three steps we have to be done in this project. So we start from the total load and demand calculation, because this calculation can help us to determine the size of the solar PV system required for this residential house. Okay, and then the last one is the selection of the protective device like the MCCB, MCB, and also the RCCB. Okay, actually this device, okay, can uh, prevent the accident from happening in case there is a fault happening in the system. Okay. Okay, so now we move on to the problem statement part. Okay, so there are three problem statements here. The first one is the rising cost of electricity bill due to the growing reliance on the electrical appliance and device. Then the second one is the issue of climate change has become one of the widely discussed topic globally. Actually, the government has advocated so many times regarding the renewable energy. So this project actually can beneficial to the to the environment lah. Okay, and then the last one is the lack of reliable access to electricity due to the grid limitation. Okay, and also we have three objectives here. The first one is the we want to design and implement a provide size of a size of grid solar PV system for this residential house. And the second objective is to ensure the solar system can operate at its optimum level based on the total demand load calculation that we did lah for these houses. Okay, and then the last one is to select the most suitable rating for the protected device.
Hello everyone, my name is Muhammad Nazrin. Now I'm going to talk about the environmental impact. The first one is the greenhouse gas emission. It is a conventional power plants, particularly coal-fired ones, emit significant amount of carbon dioxide, CO2, and other greenhouse gases, contributing to the global warming and climate change. The other one is air pollution. It is a fossil fuel combustion release nitrogen, oxygen, and O2, and sulfur dioxide, which can cause acid rain and respiratory issue in humans and animals.
So then the next environmental impact is the resource depletion and habitat destruction. This the extraction and transportation of fossil fuel, for example, coal, oil and gas, will lead to habitat destruction, land degradation, and oil spill, negatively affecting the ecosystem and biodiversity. This activity also reduces ecosystem ability to provide essential service like clean air, water, and fertile soil. The next one is for the fourth environmental impact is the toxic waste and water pollution. Coal-fired plants generate toxic ash and saline containing harmful metals like mercury, arsenic, and lead. This pollutant can sweep into the water and soil, causing a long-term contamination. This poses risks including the neurological damage to human and harm wildlife. This will disrupt the ecosystem for a year if we didn't take any action for this.
Okay, I am Charles Felix. So I will present a proposed design. So this is the design for the Pendeka Musta house. We have six fluorescent lamp, six light bulb, and four ceiling fan. We have one wall exhaust fan, two air conditioner, one washing machine, one dryer, one TV, one water heater, and one refrigerator. So this is the total power of the appliance that we get from our research, and then the total power we get 11.3 kilowatt. So this is the design. We have the appliance here, and that's all. So next we have solar panel on the top, and the solar panel will uh, flow the energy to the charger controller, where the charger controller will store the power to the battery, and this power will be used by the DC load on the left side and AC load at the bottom side. But we have before we have AC load, we have the inverter. So the function of inverter is to convert the stored battery power, which is in DC, into a type of electricity used in our home, which is AC. And the function of the charger controller is used to regulate the power from solar panel to protect the battery from overcharging or over discharging. So this is the calculation that we get. So first we will calculate total connected load. So the total connected load is the sum of power rating of all devices connected to the electrical circuit measured in watt. So here we get our total connected load is 11.3 kilowatt. Next we will calculate maximum demand. Maximum demand is uh, the highest level of electrical power required by a system or installation during a specific period. So to calculate maximum demand, so the total connected load, we times with demand factor, which is 0.7, and then we get 7,910 watt. So the last, we will calculate the total design current. Total design current represent the electrical current required by a system under its maximum load condition. So we use this formula, which is total design current equals to V max over V time with power factor. So we have our power factor 0.85, and then we will get the total design current, which is 38.77 ampere. That's all from me. Thank you.
Hello, my name is Lin Zhonghao, and I'm going to present the selections of MCB and RCCB. So the MCB and RCCB we choose in our project, which is Panasonic MCB double BD121321B double H, and RCCB we chose in which is Panasonic RCCB double BDR24030H. Why we choose this MCB as our main use MCB in our project? Because our project design current is 38.77 ampere, and this MCB is 40 amperes MCB, and its current is rather higher than the design current to handle the maximum load. So this MCB can provide the overcurrent protection to prevent the damage from the overloads or short circuits. And it also can become a safeguard to protect the main circuit supplying power to the entire house. And for the part of the selection of RCCB, because the sensitivity of our RCCB is 30 milliampere and is ideal for the personal protection in a residential use. It also can prevent the electric shocks and minimizes the fire risks from earth leakage currents. It is rated 63 ampere RCCB and is adequate for the total load, which is 38.77 ampere. At the end, this RCCB is chosen because it ensures the leakage current protections and an overall system safety. And it comes to the calculation part, and we can see that the maximum energy demand, the maximum power is 7.9 kilowatts. And let us assume that the hours of usage is 6 hours. The peak sunlight hours is 5 hours. And the solar panel power rating is 300 watts. And we can see that the total energy consumption per day, it refers to the amount of the electrical energy used by all the devices, appliances, or system in the building or set out over a 24 hours period. And we can calculate that our total energy consumption is 7.9 kilowatts times 6 hours, and we can get 47.5 kilowatts per day. And after that, we can calculate the total power needed from PV panel, which refers to the total amount of electrical power that a solar photovoltaic system must generate to meet the energy requirements of a specific load. And the total power needed from PV panel is total energy consumption divided by the peak sunlight hour. So our peak sunlight hour divided by 5 hours, so we can get 9,492 watt. And after that, we can calculate the number of PV panel needed. So the number of PV panel needed refers to the total quantity of solar panels required to meet the desired energy demands of a system based on the total power needed from the PV array and the individual panel specifications. So the total power needed divide the power generated by each PV panel. We can get the number of the PV panel needed. So the 9,492 watts divided by the 300 watts, we have get 32 panels. 32 panels. So 32 panels is needed in our project. That's all from me. Thank you.
For conclusion part, first, a solar PV system is the best of breed energy solution for Pendekar Mustar home. Second, to ensure it works well, consider the specification of all home appliances. Third, focus on key factors like total load, maximum demand, design current. Fourth, proper calculation help choose the right component, including solar charge controller, inverter, and battery.